I released a video where I talk about some basic optics, and Nathan Oakley responded to it with some, nonsense. Now, I said I wouldn't do a response, but I've been receiving a few messages asking me to, and fuck it, why not do a quick one? The flat earth community is all in a tizzy about the images of some oil rigs, and I have to say, well done. Well done for fucking things up so spectacularly, but mostly well done for the marketing. Calling this image the Black Swan really is a good move, and it shows that some flat earthers may have actually read something.
So, AB Science is the latest to walk into a string of flamethrowers with regards to the Black Swan.
Yes, these are some really impressive flamethrowers you have there, Nathan. Actually, all I'm seeing is some flat earthers with a dodgy lighter trying to burn some meth, but I'm not too bothered about semantics. If you want to call it flamethrowers, then go for it.
He makes an attempt to debunk this, and we'll go through some of his remarks in regards to the imagery and its justifications therein.
I do generally find it quite funny when a flat earther says that I'm trying to debunk flat earth. It generally shows that they haven't understood a word of what I present in my work, and they have completely missed the point. But anyway, Nathan, please, go ahead. Let's first address the modus tollens thing.
Modus tollens states, if P, then Q, not Q, therefore not P. If P, we live on a globe of radius 3959 miles, then Q, every horizon distance measurement cannot be more than 1.23 miles times the square root of the observer height in feet. Not Q, the geometric horizon is far greater than 2.73 miles for 5 foot. Therefore, not P. The Earth is not a globe.
If we take the following statement that if the Earth is a sphere with a radius of 6,371 kilometers, then at an observer height of 1 foot, or 30.48 centimeters for those who are sensible, the horizon should be 1.9 kilometers away. Now, this is a simple statement, if P, then Q, or formally written as this. And we then observe that the horizon is clearly farther than 1.9 kilometers away, and we can then conclude that the initial statement is incorrect.
This stage, we have AB Science describing a horizon, singular, the horizon.
That the horizon is clearly farther than 1.9 kilometers away.
Later in the presentation, AB Science will have us using two horizons, a geometric and an apparent redundant term, horizon, which he'll substitute in with actual geometry and donkey dick geometry.
But we cannot know what about it is incorrect. You see, the statement P is if the Earth is a sphere with a radius of 6,371 kilometers. And our result could mean one of several things. The first is that the Earth is not a sphere. The second is that the Earth is a sphere, but the radius is not 6,371 kilometers. And the third is the statement is incomplete.
So the first statement, the Earth is not a sphere, would be correct based on the geometry and physicality claimed at the given radius. The second statement is that the Earth is not a sphere but with a radius that's apparently fixed in stone and has geometric physical proof to back it. That would be the same as number one, the Earth is not a sphere. And the third statement would be that it is incomplete to state that the Earth is a sphere with a given radius value. We would also agree the Earth is not a sphere.
How? I mean, how? How is it possible that you did not understand this rather simple logic? Okay, Nathan, I will take this very slow, as it is very clear that even baby steps is a bit too fast for you. You see, the premise is as follows. The Earth is a sphere with a radius of 6,371 kilometers. There are two components to this premise. Component 1, or P1, is that the Earth is a sphere. And component 2, or P2, is that the Earth has a radius of 6,371 kilometers. And the logical conclusion is that for an observer height of 30.48 centimeters, the horizon should be 1.9 kilometers away. Now, this conclusion comes from the following maths. The horizon is an imaginary line, and at any point along the line, one can draw another line between that point and the observer. This line will then be tangent to the Earth's surface at the point on the horizon. From the small angle approximation, we can actually use the 8 inches per mile squared formula, but then in sensible units. Now, what is previously taken as the drop height is now the observer height, and then we just rearrange it for distance. We plug in the numbers and we get 1.9 kilometers. If the observation is inconsistent with the logical conclusion, then there are several options. Either P1 or P2 is incorrect. Both P1 and P2 are incorrect, or the statement is incomplete. Now, if P1 is incorrect, then it follows that P2 is incorrect. This is because P2 states that the Earth has a radius of 6,371 kilometers. But if P1 is incorrect, then there is no sphere to have a radius. So this is the same as both P1 and P2 being incorrect. However, P1 can be correct without P2 being correct. That is to say that the Earth could be a sphere, but the radius is not 6,371 kilometers. And this leaves three options then, that P1 and P2 are incorrect, P1 is correct, but P2 is incorrect, or the statement is incomplete. And this is expressed in this screen I showed on the original video. All the modus tollens thing shows is that there is something wrong with the premise, but not what is wrong with the premise.
The premise being incorrect is very straightforward. It is asserted that the Earth is a sphere with a given radius, and that has fixed geometry. Metaphorically, and reified by fundy idiots, this would be set in stone, if indeed we did stand upon a sphere. Debunking the assertion of the modus tollens argument leaves you with only one conclusion. The Earth is not a sphere, with a radius which should be set in stone.
So you are completely missing the point then. Considering how much of a boner you have for formal logic, you clearly don't understand it. There is a really simple and very important concept you have to remember, and this is setting your problem up correctly. You see, the distance to the horizon that is quoted in the problem statement is the distance to any point where a line tangent to the surface of the Earth intersects the observer's eye. And this is what we refer to as the geometric horizon, and it is the horizon that we would observe if and only if the Earth were a featureless sphere with no atmosphere. Are you starting to see how the statement is incomplete? We then have to take more information to figure out what the hell is going on. So we can take this image and we conclude that yes, the Earth is definitely a sphere. And
the old present a white swan and declare that the physical geometric horizon is once again physical, geometric, and obscuring things in the distance based on Earth geometry.
Wait, hold on. Where did I say anything like that? I merely state that from this observation we can only conclude that the Earth is indeed spherical. So let's go back to how I broke the premise down. We have option 1, which is that P1 is incorrect, and by extension P2 is incorrect. We have option 2, which is that P1 is correct, but P2 is incorrect. Then, of course, we have option 3, which is that the whole statement is incomplete. And all this image shows is that P1 is correct, because this observation is only possible on a sphere. I haven't actually said anything about the location of the horizon yet.
Now, obviously, that would require the horizon to be physical, geometric, actual, and capable of blocking something in the distance, as your physical geometric maths asserts. But later we'll find that he has a bit of an issue with asserting that we have a physical geometric horizon.
Maybe the Earth's radius is not what we thought it is. But then we pick more images, and then it looks like if we take option 2 to be correct, then the Earth's radius appears to change. And this depends on the weather conditions.
AB Science now hand waves the idea that we should have a physical geometric horizon. That would be absurd. The physicality asserted by the geometric calculations would vary based on the weather. How dare we assert that you have a physical geometric horizon?
Interesting how you cut that, Nathan, whilst also once again being too thick to understand what I said. Now this is what Nathan presents. But then we pick more images, and then it looks like if we take option 2 to be correct, then the Earth's radius appears to change. And this depends on the weather conditions. And this is what I actually said. But then we pick more images, and then it looks like if we take option 2 to be correct, then the Earth's radius appears to change. And this depends on the weather conditions. This is pretty silly. This is pretty silly. This is pretty silly. This is pretty silly. Sorry, Nathan, I know it is hard to resist editing the video so you can misrepresent what is being said. But just remember that I phrase certain things in just the right way so people like you can do exactly what you did, because it tends to demonstrate how dishonest people like you are. But Nathan is missing the point here, so I will have to go through this again in baby steps. We have already established that P1 is correct with this image. And we are now looking to see what could be wrong with P2. When we look at different pictures, we see that the distance to the horizon changes. Now, if the logical steps that lead to the conclusion are correct, then this would mean that the Earth's radius changes, and it would appear to change based on the weather. And this notion is ridiculous, and this shows that the whole statement is incomplete. At this point, we actually have to reconsider it. So we can take the statement, if the Earth is a sphere with a radius of 6,371 kilometers, then for an observer at a height of 30.48 centimeters, the horizon is 1.9 kilometers away. But we have to then add a word here to make the statement complete, or actually specific, and that is the word geometric, because that is what this equation describes. But that is a statement that is pretty difficult to test, although not impossible. But if we are talking about the horizon that we actually see, then the original statement is woefully insufficient because it doesn't take refraction into account. And all you are then left with is, if the Earth is a sphere with a radius of 6,371 kilometers, then there is a horizon some distance away. Not too close, not too far. How far? Well, we can't really tell unless we know exactly how the refractive index varies between the observer and the horizon. But remember that we have already determined that the Earth is a sphere by virtue of this image, because once again, this is indicative of the Earth being a sphere, and all we are trying to establish here is the radius of said sphere. And then from this statement, it is pretty clear that this cannot be done using this method. Anyway, let's have a look at the images and consider what is going on. Now, I will preface this with saying that a picture is not worth 1,000 words when it comes to science. Without controls, calibration, and exact information about the environment, they tend to be worth fuck all.
Following on from his summary at the beginning of his video, a straw man must be burned. Nobody at any point of this logical consistency argument has asserted that we have science.
Well, it's very clear that you don't.
However, it seems that straw man that is often asserted by fundamentalist religious zealots on the globe side of this argument needs debunking out of habit. We haven't asserted science. It is not us that claim natural phenomena when none exists, but you feel free to burn this straw man.
Ah, classic Nathan. Step 1, misrepresent an argument. Step 2, claim that the misrepresented argument is fallacious. Step 3, commit argument from fallacy. You see, I am not claiming that you claim to have science. I'm just making a statement on the tendency of flat earthers using pictures as evidence, and a statement around the weight that we should give that evidence. But here we definitely see that the horizon appears to be quite a bit farther than 1.9 kilometers. So what could be going on here? Well, we could be talking about density gradients and temperature gradients and yada yada yada, refraction. Now, what kind of refraction? Actually, I don't give a shit.
Well, you should really care, as the refraction used in your geometric mathematics is based on geometry. Terrestrial refraction, if you're talking about the sphericity of an Earth that's sphere-shaped, would be a reification of an R value into a refraction value mathematically based only on the radius value, giving you a physical geometric horizon to bend the light at the rate of 7/6R in the case of standard terrestrial refraction's actual effects, which don't exist beyond the mathematics of the geometry.
You didn't understand a single word of the video, did you? I'm a physicist and I couldn't give a damn about how you want to label how refraction can manifest in different ways.
So get this, he's a scientist who doesn't care about how things manifest. What, natural phenomena and the cause thereof? Yeah, why would you be interested in that? What with science being the establishment and elucidation of the cause of an effect. But yeah, why would you concern yourself with such things? You're a scientist. You've got stories to make up and horizons to create out of redundant terms like apparent. That's science, right? No, you fool. Science would be the elucidation of cause when studying effects.
Now, this is one of those instances where I chose a particular phrasing so whoever would respond would make a big hoo-ha about what I said. The aim would be that the respondent would make a big, grandiose statement and thus revealing their arrogance as they talk about something they clearly don't understand. You see, when desperate people try to make a point, they tend to ascribe different meanings to a sentence. Now, I could have gone for a simple, it doesn't matter what label you give it, it is the underlying mechanism that is important to a physicist. Simple and clear. But having heard a bit of a discussion between MC Toon and Austin Whitsitt, I knew that it would be interesting to see how flat earthers would respond to the phrasing that I did end up using. I understood full well that even though I said, I'm a physicist and I couldn't give a damn about how you want to label how refraction can manifest in different ways, chances are that there would be a flat earth out there who would hear, I am a physicist and I couldn't give a damn about how refraction can manifest in different ways. Now, it was a long shot, but I thought that there may be a small chance that someone would jump on that. Care about the fact that there is a wave of some sort, and the direction of this wave changes when it hits a different medium. And this is what we will be talking about. Now we will be working in 2D, so its components are given by 2π. There is a beam of light hitting an idiom 1, which is given by this expression to be a continuous function. What this means is that at the lambda 2, so the wavelength clearly, lambda naught, cancels out. So we are lighting it in and we get, because this means that we could possibly make a material where we can slow light down. Now, a number of research groups are heavily involved. One, you will know encrypts and that this doesn't prove anything. I give you this video. The refractive index of these parameters change over the path of the beam, and this is the reason why I said earlier that in science a picture is definitely not worth 1,000 words.
So, after a very long and boring presentation about light and what it does, we come to his actual conclusion, which is to say, the horizon is refracted. So I may as well just demolish his point immediately, which is to say that we only have one horizon. The horizon in his geometric model is of course geometric. The refraction in his geometric model is based on r, giving him a physical geometric horizon. So his bullshit swindle now begins, and he inserts his second horizon, utilising the term apparent, not realising, like many of the idiots who have discussed this black swan argument, that the term apparent is already included in the definition of a horizon. That would be the apparent position, where the sky meets the ground, or the position where the sky appears to meet the ground, apparent being entirely redundant.
Okay, Nathan, you got me there. From now on, I will just use the word horizon instead of where I previously used apparent horizon. Now, personally, I prefer to emphasize the apparent bit when trying to differentiate between the geometric and the actual horizon. You see, earlier you said this.
This stage we have AB Science describing a horizon, singular, the horizon.
And later you complain about this.
So his bullshit swindle now begins, and he inserts his second horizon.
Now, did you not think for a second that at this point I started differentiating between apparent and geometric to clearly separate them for narrative purposes? But you can make some pretty easy approximation. I will draw a hand-wavy diagram of how the curved path affects what we can see. So here we have a person standing on a sphere, and there is a green line tangent to the sphere which also intersects the stick figure's eyes. And
So here we go with our two horizons. We're going to be performing actual geometric calculations based on the green line that we cannot see, giving us a geometric horizon that doesn't exist, and another redundant term usage of the word apparent horizon. Hooray for the usual bullshit from globeheads who don't understand the argument and appreciate they require a geometric horizon.
and this indicates the location of the geometric horizon. We then have some oil rigs which are just beyond the geometric horizon.
The oil rigs are just beyond a geometric horizon that we don't experience, cannot see, and yet he's drawing a line to it to perform the geometry required to employ terrestrial refraction at 7/6R and give him a second refracted horizon that's apparent in the distance? Well, we'd need that first geometric horizon. Where the hell is that if we can't see it? How are we going to draw a straight line to it, AB Science? You'd require a geometric horizon for this explanation, now wouldn't you?
I would still be interested to see you point out where I perform those calculations. I'd be really interested to see that. You see, had I known that it would be Nathan responding to this video, then I would have done something a little bit different. I probably would have just taken an equation and just replaced one of the symbols arbitrarily to R, because I know how this letter triggers him. It's feasible for the apparent horizon to be behind the oil rigs. In contrast to other videos, I didn't actually perform the calculations for this bit, and it's actually just a picture I drew. I like to be transparent and show every step of the way, and that is just not feasible for these kind of calculations.
At least at some scale, AB Science understands that he does require a geometric horizon to draw a straight line to, even though he's got an explanation of precisely how not straight and bent those lines actually are. So, we only have one horizon. The horizon in your geometric model is physical and geometric. The apparent horizon, as you're describing it with this redundant term for the apparent position where the sky meets the ground, is not a physical horizon as demonstrated in your geometric model. You absolutely require a physical geometric Earth curve to be in visible actualization and block things in the distance, as demonstrated by your example of a white swan. Unfortunately, it's not your choice whether the horizon is physical on one day and not actual refracted apparent on another.
Now, earlier Nathan accused me of strawmanning his argument, which is funny. Where did I claim that the horizon we observe is either the geometric or the apparent horizon? because it is always the apparent horizon. And this is implied in the definition of a geometric horizon being the horizon we would observe if the Earth were a perfect, featureless sphere with no atmosphere. Considering that the Earth is not featureless and definitely has an atmosphere, we are not going to see the geometric horizon. But here's the problem. The conclusion to your problem statement is that the horizon should be 1.9 kilometers away from the observer, but this is based on a calculation for the distance to the geometric horizon, the one that you claim doesn't exist. Nathan, how can you not see the problems with the whole black swan thing?
You have failed to debunk the black swan. You require a geometric horizon. The horizon we experience absolutely is not geometric.
Spot on, Nathan. So you understand that what we see is not the geometric horizon. So why do you compare the distance of what you observe to the distance of the geometric horizon? But I forget, you know that you are full of shit. I mean, we have all seen the screenshots. But anyway, remember how I said that I find it funny how he claimed that I tried to debunk the whole black swan nonsense? Well, the way he edited it makes it look like that. After all, this image features heavily in his presentation. However, in the original, it is on screen for less than 30 seconds. The video was actually about Snell's law, and the first of the videos I intend to do on optics. I think that the next video on this topic will probably involve this equation. I don't try to debunk flat Earth. I just take this nonsense to try and create an educational presentation. It just so happens that the presentation debunks flat Earth. Take the original video, for example. All I do is use the black swan to discuss a simple failure in problem solving and then create a setup to explain how refraction actually works. Thing is that if you accept the explanation for refraction, then you cannot deny the conclusion. So all in all, the black swan image doesn't really prove a damn thing, and there's nothing in there which would give any person reasonable cause to question the established theory, but it does give a nice opportunity to talk about other things. So funny how you cut that one out as well. Anyway, that was it from me. This was pretty light touch as well. Nathan doesn't really say much, and regardless of how much of an asshat he is, I'm not in the habit of bullying people.